morning, everyone, and welcome to today's webinar, How to Overcome Your Biggest Collaboration Challenges, What CIMdata has to say about Vertex. My name is Rachel Casciato, and I will be your moderator for today's webinar. Joining me today are Vertex Product Marketing Manager, John Heller, and CIMdata Executive Consultant, Ken Versprille. Before we get started today, I have just a few housekeeping items I'd like to go over. Everybody attending the session today is in listen-only mode, but we'd love to hear from you through the questions box in your control panel or by tweeting us at @VertexVIS. We will be answering your questions at the end of the webinar today. And now I'm pleased to introduce all of you to Ken and John and tell you a bit about their background. John Heller has extensive experience in mechanical engineering, supplier collaboration, cross-functional relationship building, and procurement activities. As product marketer for Vertex Software, John leverages his background in engineering and product lifecycle to best understand and communicate pain points and opportunities for improvement in manufacturing organizations. Ken Versprille is an executive consultant at CIMdata with responsibility covering the full product model creation and design collaboration workflow. As an executive consultant, he works with both solution providers and industrial users. And now I'd like to turn it over to Ken.
Thank you, Rachel. I'd like to especially thank Vertex Software for inviting me to speak today. Welcome to you all, and thank you for taking time out of your schedules to attend this webinar on understanding the barriers imposed on users who use the most common collaboration solutions available in the market today. The industry is beginning to see efforts to break down the barriers to collaboration. As Rachel mentioned, my name is Ken Versprille, and I'm an executive consultant at CIMdata with responsibility covering the full product model creation and design collaboration workflow. I have deep technical experience in CAD and 3D geometric modeling. As an executive consultant, Rachel mentioned that I work with both solution providers and industrial users alike. I've been with CIMdata since about 2011, when the company acquired CPDA for Collaborative Product Development Associates, which was the PLM spinoff of D.H. Brown Associates, where I held a similar position for over 10 years. Prior to that, I was with Computer Vision in the 70s and 80s, where in the R&D organization, I designed and implemented CAD systems. You can read the rest of the slide details on my background on your own. Suffice to say, I've worked on the R&D developer side of CAD prior to my shift to consulting, and I have extensive experience in CAD and 3D geometric modeling since obtaining my doctorate degree from Syracuse University, where I was lucky enough to study under Stephen A. Coons, who is now considered one of the pioneers of computer graphics. If you will allow me a short mention of CIMdata in case you are not already familiar with us as a company. CIMdata is the leading strategic management consulting and research firm focused exclusively on PLM. We work with both providers and users of PLM technology to maximize their efforts to deliver products and solutions to the industry. We remain unbiased advisors in the PLM industry in that we do not sell or market any software or hardware solution. Our services are structured in the three main areas of research, education, and consulting. We offer our clients not only market research and analysis, but also deep technology research in a wide range of areas, such as CAD, CAE, additive manufacturing, collaboration, and overall product development workflow. But let's now turn to the topic of interest. In my presentation today, I will engage in a discussion of collaboration, specifically product design collaboration. I will first offer 4 takeaways I hope you will remember from the discussion. I will then begin with a definition or taxonomy of collaboration that CIMdata developed a few short years ago, working with major aerospace OEMs. Then we will turn to the challenges with collaboration that users in numerous industries from around the world have voiced to us over these past few years. I will break them down into process-related challenges or content-related challenges. Once we've explored and understood the problems, we can turn to guidelines for better solutions and the promise of more recent technologies to aid in those improvements. Well, let me begin with the 4 takeaways I'd like you to remember. And as I go through them, think about your own experiences with collaboration and how they might relate. First, the users I speak with collectively agree that their most serious problem is the variation in the collaboration mechanisms they need to put in place to collaborate with different suppliers and different organizations or silos within their own company. For example, the varied mechanisms can offer suppliers access to the OEM's product data repository within their firewall or a repository staged outside the firewall. Access can be through transmitted files either by email or FTP. Next, always be aware of security and intellectual property protection. You shouldn't invite a supplier into seeing your company's best guarded secrets with open arms. Have safeguards in place and adhere to them. I just participated in a collaboration discussion last week with a medical devices company. A number of their staff were shocked to discover they allow their suppliers uncontrolled access to all their CAD data. Third, you need to recognize that different organizations and/or companies bring different skill levels to the collaboration effort. What may be easy for one set of team members to handle might well confuse another group in the team. Finally, you must deal with cultural changes and controls in the collaboration process, especially dealing with product change during the design process. One of the more often mentioned extreme examples of this is collaborating with a manufacturing shop floor individual with a 3D model who has only been used to dealing with 2D paper drawings. Okay, let's now turn to the product of design collaboration itself. In working with clients, CIMdata has developed a definition of collaboration to be both the data, the standards, and the process, including what we call the mechanisms of data sharing between partners, be they OEM to supplier or engineering to manufacturing, sales, services, or procurement. Collaboration deals with the sharing of both data content in the form of text, geometry, and/or numbers, and visual content. CIMdata dissects collaboration into program phase, the when, collaboration entities, the who, the purpose of the collaboration, the why, the collaboration environment, the where, such as inside the firewall, outside, or elsewhere, the content, the what, meaning the actual data being shared, and finally, what is being done with the data, the how, of how is it being used. Here, for example, we might talk about clash detection or CAE analysis, or manufacturing process planning. So we have 6 axes of definition, and you can apply that definition to whatever granularity is your particular interest or problem. It's that selectable granularity that I believe makes this taxonomy so flexible. For example, when it was used by those aerospace OEMs I mentioned, they chose the granularity of collaboration entities, the WHO, to be types of suppliers, such as design and build partners, build to print suppliers, and so forth, because they believe that different types of suppliers are treated differently during collaboration. You might choose to select very different collaboration entities. Say, for example, the collaboration is between different organizations within your company. The WHO might be engineering design, CAE analysis, manufacturing, tooling, services, etc. We now turn our attention to the challenges that users report with their collaboration efforts. As I said earlier, for the most part, they fall into 2 categories: process-related and content-related. That is, they are clustered on the 2 axes of the CIMdata taxonomy, the where axis and the what axis. On the process side, I already mentioned installation issues and that the OEMs find that every setup is different depending on the collaborating supplier. But users also complain about ease of use of collaboration tools and the process issues they must deal with in an asynchronous data exchange. I'll delve deeper on all these in a moment. On the content-related side, the biggest by far issue is the data is often massive. The design may be of a simple bracket, but more likely something very large, like a tractor, an automobile, an airplane, or even an aircraft carrier. Then we get into the IP, intellectual property protection issues, and in some industries into export regulation issues. So I'm ahead of myself here, I'm sorry. Not going backwards. There we go. Sorry for that interruption. First, installation on the process-related changes. Again, this is the #1 problem I hear mentioned by companies. Every one of their collaborating partners has a different setup for data exchange. They all use different tools and, more importantly, different infrastructures. Inside the firewall, outside the firewall, FTP, even email. The list is endless and growing. They might use any one of possible commercial cloud data exchange mechanisms, from Google Drive to Dropbox, OneDrive, Amazon Drive, Box, and that list goes on and on. The complexity of supporting and managing a number of these mechanisms is cost and time intensive for the OEM, and for a supplier who collaborates with multiple OEMs. Then there's ease of use. Not only does it apply to the installation variations, but also to any given collaboration tool itself. What does it take to initiate a data sharing? Once you receive that data, what steps do you need to follow to access it and use it? Any complication that users have in dealing with this in itself can cause more problems. Then there are two related issues that I call bi-directional agreement and asynchronous exchange. With all this product design data moving back and forth between collaboration participants, the data is really being worn down in many ways. The collaborating partners may use different CAD solutions or different revisions of the same solution. Data translation tools from different vendors might introduce slight errors. Everyone complains this whole process needs to be simplified. And with asynchronous exchange, you need to recognize that once the data is shared, it doesn't remain static. The OEM might pass the data to a supplier, but then usually continues on advancing the design. The supplier is now holding old data. Remember that no matter how good you are internal to your company in maintaining that so often called the single version of the truth, once the data is shared outside, you lose control across the supply chain. Then we have connectivity optimization. The limitations of current connectivity technology can affect the speed and timeliness of data availability. Typically, the availability is agreed to by the two parties involved in the collaboration, and the data exchange is synchronized at the minimum level of the two parties. This issue overlaps somewhat with the installation concern I mentioned earlier, but it can go even further. Considered a product design effort that is being worked on by partners around the world in different time zones. They may all share data using the same exchange mechanism, but the availability of each to be responsive in a timely manner will vary. Then there's bandwidth limitations. What you can move around here at your location may not be possible with your supplier in their location or with their infrastructure. On the content side, every industry has seen a dramatic growth in product complexity over the past few years. There is no denying the expansion of electronics, electrical, and software in today's products, but mechanical systems are also increasing in complexity. In addition, customers continue to push for customization, growing the diversity of product configuration. The older methods of data sharing by copying files from one site to another are overtaxed today. Then the problem of protecting your company's intellectual property comes into play. Does your staff even know what in your products constitutes intellectual property? If they don't know it, how can they prevent it being shared? One key point is to understand that the end resultant shape or function of a product is not necessarily IP, but the methods of its model construction is. Sharing native proprietary CAD data can often expose those methods. I always like to consider the simple example of a complex parametric formula that is intellectual property to a company. Do you want to manually go through all your models, removing those formulas before sharing with a supplier? And in some cases, such as those aerospace clients I mentioned, when dealing with international data, governments get involved. It's against the law to share certain data. So what should you do? And really, what can you do? At CIMdata, we suggest you build yourself a checklist of all the issues you have had or continue to have with collaboration. Explore the causes of each one of them. This will lead you to the requirements you have for a good collaboration solution. There are, however, some guidelines we recommend you should follow. 1, strive for the most simple installation mechanism. Given the new technology directions, it will likely be cloud-based. It should avoid having to install on-premise software. 2, look for ease-of-use solutions. It, of course, should handle all the data formats you must deal with, and maybe it can support a one-click initiation of a collaboration session. Be aware of shared data that can be quickly out of date. And finally, be vigilant about security and IP protection. One idea CIMdata often recommends is that you collect your proprietary intellectual property model data into a separate component file and do what we call black box it, meaning the component provides a 3D spatial boundary, but not internals of the component that are shared. Define rules and keep with them. Thank you. Back to you, Rachel.
Thanks very much, Ken. I'm going to turn it over to John now.
Okay, yeah, thank you, Ken. Thank you, Rachel. And so, as Ken mentioned and walked us through some compelling thoughts to think about as we think about collaboration, we see that there continues to be limits in collaboration that truly prevent organizations and those outside engineering as well as the organization from truly seeing the whole story. Data sets aren't getting any smaller. In fact, we see that they're growing exponentially in complexity and scale. So one key thing to point out with Vertex, again, we are not in a state where we are replacing PLM tools, but rather extending the value of your investments in these tools for the purpose of collaborating outside of engineering. And really, if we think about Vertex and its mission and the goal and what we're trying to do in this marketplace is that we understand that engineering data has been challenged when it comes to distribution across the enterprise. We see that device dependency has been a concern. As we heard Ken mention as well, the issues around security and the amount of information that's available outside of your organization or even outside of engineering is a concern. And then in order to mitigate some of these concerns, perhaps individuals in engineering and teams around them have had to spend considerable amount of time prepping files and reducing them to a state that they feel comfortable to share outside the organization. So keeping some of these challenges in mind, really what Vertex has put together is a 100% cloud-based solution around a platform of engagement. And so with that in mind, let's jump into a quick demo of the Vertex platform. And pulling it up here. Good, so let me just back out just a minute here. So as Ken mentioned in some of his comments made earlier, and as I alluded to in the introduction here, Vertex is a 100% cloud-based platform. And the access into this platform is simply just a web login. There's no need to download any software, install anything on your device. As long as you've got cellular or internet connection, you're able to access the Vertex platform. So I'm going to go ahead and log in here. And that's going to bring us into what we call here is a workspace screen. A very simple landing page of sorts where you can access all of the information that you need to collaborate on with who you choose in a secure manner. And so we really took simplicity in mind, understanding that this should look very similar to kind of like a Dropbox or an FTP As far as the usability, not a lot of training required to really dive into the specifics of it here. And as you can see here in this workspace, we've got a couple of different screens that you can choose from. You've got sort of an all, which would show all of your models and your stories that you've brought in. You've got your models list here, you've got your stories list here, and I'll explain what those are here in just a minute. But I would say a very key part of being able to get your information into a state where you can collaborate on is really just simply this import button here. And this is a very easy way of pulling in the model information that you need to collaborate on. Currently, right now, we support all neutral file formats, the major ones, as well as native CAD formats being brought in. Additionally to that, and to make it easier to sync and to collaborate on your data out of your CAD and PLM systems, we do have available upload APIs that we can work with you to establish some type of a regular cadence of upload of files as they are revised into the Vertex platform. And so that just real simply kind of gives you an idea of how you bring models, and I've got kind of a list here of an example of models that we've brought into the Vertex platform. But one thing I just want to touch on briefly here, and as we sort of introed this demo, was really around seeing the whole story. And what we really feel passionate about here at Vertex is the struggles that organizations have in collaborating on heavy product data and product design, and really being able to collaborate on those models and that information outside of engineering. Obviously, companies are looking to improve their decision making and move it forward, so to speak. And the only way you can do that is bring in the necessary decision makers in order to reach a decision quicker. And so to kind of give you an example of what we mean here by a story, I've just pulled up an example of what we call a story here, and I've titled this a yaw pitch motor failure. And for the subject matter of this demo, we're going to be looking at a wind turbine. And so to kind of give you an example, this is a story, which would be a collection of various snapshots that have been put together to describe an issue centered around this yaw pitch motor failure in the field. And so this individual has put together several different snapshots, and I will show you here in a little bit, again, taken from a full engineering BOM, and taken these snapshots to provide context to the issue. And so we can see here that we've drawn attention to this highlighted motor that's causing failure in the field. We're specifically seeing issues with this planetary gear. The field service people believe that one of the main issues is around this torsional force of the shaft causing failures out in the field. And then to further define that, we might have a recommendation from the field to say, we believe the distance between the motor and this planetary gear needs to be shortened. And so that's just what we mean by a story. It's just a context of an issue and an attempt to bring the necessary people into your story and collaborate on it and reach a decision. I might also show you another example, again, of how you might collaborate outside of engineering, and just the experience that this platform and the breadth that this platform brings with it. Is now another example is where somebody in sales is wanting to make a pitch to the wind turbine manufacturer about their blade designs. So they put together, again, a series of snapshots to highlight here some different functionality that they would like the manufacturer to see. And so they've just told their story with some dimensions, with some visuals, with some commenting, again, being able to utilize some tools to make their point in this story. So that's what we mean by a story. And now I'd like to drill down just a little bit about some of the powerful capabilities within the story. If I come back to this yaw pitch motor failure story here, we'll see that, as I mentioned before, we've got a collection of snapshots, but these aren't just your ordinary snapshots as somebody might be used to seeing in a PowerPoint presentation. Perhaps somebody's taken a screenshot of something, or they've had to go out and create a separate model, so to speak, that's fully separate from the source of truth. These snapshots are fully immersible. And what we mean by that is you can actually get into these snapshots, you can interact with them in 3D. Additionally, you've got your comments here. With these snapshots, you're also pulling in a fully interactable bill of material. So if you notice here in my screen, if I click in the model viewer aspect of that, you'll see that it highlights in the bill of materials. So you can perform various functions in here. Let's just say I want to hide that, and that removes that base if I needed to look under it for any reason. I can also reset that snapshot back to its original view as well. So again, these snapshots are fully immersible, fully engaging, and in a way that provides fully aligned visuals with your context of the issue that you need resolved. Now, the other thing that we've got built into these stories, and as Ken alluded to, and one thing that we've kept in mind is the security around your story and the IP concerns that many companies have in putting their data out to either a supplier, to a customer, out in the field, etc. You'll notice here with each individual snapshot, I have full control over what an individual is able to do and interact with. I can come to any individual snapshot and I'm able to have full control over whether I enable the recipient of this story to export. And what we mean by export is that if I enable export here for this snapshot, they will be able to export out the geometry only for what is shown in this particular snapshot with its associated bill of material. Even though I've shared this entire story with them, they're only going to be able to pull out the information from this one snapshot. Additionally, if I want to further enable functionality within the story, I might come into a certain snapshot and say, for this snapshot, I only want to enable them to perform measurement. Again, just pulling some different levers from a security and a control standpoint of how you want your collaborators to engage, either to the full extent, to a minimum extent, or somewhere in between. So I've enabled, I've set my control limits, and now I want to share it out with a group. And that's just simply done by clicking the share button. You can enter in the email address of anyone that you want to collaborate with here. And in literally minutes, they can be brought into this story. And I'll show that in more detail here in a second. The other thing too, another control lever, another security level that we have built into this story is that you can allow the recipients of this story to share with anyone in their domain, or you can lock it down to just that individual with just a simple click of the button. You can also come in here and at any time remove any one or all of the collaborators from access to this story. So that kind of gives you an idea of what we talk about, what we mean when we talk about seeing the whole story, being able to pull in collaborators, being able to team instantly and securely with anyone that you need. So the other thing that I'd like to draw your attention to here as well is, as Ken mentioned, the challenge that many companies have in collaborating on massive data sets. And what I've just done here, as you've seen in a matter of seconds, is I pulled up an entire field of wind turbines. And to kind of give you a little bit of understanding what's behind this here, as I mentioned earlier, we are a 100% cloud-based solution. And when an individual wants to collaborate on a heavy data set and they import into Vertex, we put this up on the cloud, and it is now distributed across cloud servers. And when an individual clicks on the model to pull it up, as I've done here, essentially what we're doing is we're just making a call up to those servers. It's rendering an image in the cloud and then streaming the device, streaming the image down to your device. This is what truly makes it scalable and has the ability to be opened on any device, because we're not actually caching anything down to an individual's device and then requiring the computing power of that device to render the image. All of that rendering is being done in the cloud and is simply being streamed to your device. And as you can see here, as I rotate this model, it's just simply saying, you know what, my point of view has changed on this model, and it has re-rendered it in the cloud and then instantly streamed that new image down to my device. And so this would be, you know, what we consider a fairly large model. There's certainly bigger out there, but essentially we've got a field of 12 wind turbines here, and I want to just blow everything away except for that one. And I'm going to show only that one selected, and I'm going to bring that into view. So now I've got just one wind turbine out of the 12 that I've shown, and we can even further get down to detail as we zoom in to this here, and we finally get down to perhaps some detail that we want to see. So again, a very, very powerful system here that shows you the scalability of the platform and its ability to be able to take large data sets and quickly make them available for purposes of collaboration. So now I want to jump into a specific wind turbine model here, and let's imagine a scenario where we have an issue with a certain part of this wind turbine, and we need to quickly get to some views to be able to create our story so that we can effectively collaborate on that. And so we've got this wind turbine brought in here. Again, very easily and very quickly opens and loads for us. And I'll open up the bill of material here. You'll see that with this wind turbine, we've brought in the full engineering BOM. So there was no admin work done on the front end to be able to bring this into a state where we can start collaborating on it. And further, we've built in capabilities within this platform to be able to find the information you need in an efficient manner. And so for this example, let's just imagine I want to find specific parts made by a certain supplier. So we've got what we call here some advanced search capabilities with the metadata properties that are brought in with the model. Let's just say I want to search for a supplier, and I want to look at everything from our supplier NSK. I'm going to add that filter. Now it brought everything over here on the left-hand side that was made by that supplier NSK. And I in particular want to look at some issues that we've got around the main bearing housing. So I'm just going to select this one, and I'm going to say show only selected. There it is. I'm going to bring it into view here. Now I want to bring in just the things that are around that, but I don't know the names of all of those parts. And so what we've done is made it very easy and simple for you to bring back the surrounding visuals by this show only nearby. Hide this so we can get a look at it and back it out just a little bit. So you can see here within our view very quickly we've brought in context to that part, and I also want to hide this part just to kind of make it easier for us to see. I maybe want to bring in some of the other bearings that are around it for some context as well. And so I'm going to bring that back in. Now I kind of want to set my views for what I want to collaborate on. So because I want to get some different views of this, this bearing, there we go. I've just snapped it very easily to a top view. And I'm going to zoom in here. And I want to drop some markup here. So I want to draw attention to this area, for example, and say we've got some shaft deflection happening here. And I'm going to save that markup. And you'll notice when I saved that markup, it automatically created a snapshot and kept it for me over here on this left-hand side. So I've got that view quickly saved. Now let's say I want to dive into the details of the bearing itself. So we've got a couple tools to help that. I want to cross-section that. Let me switch real quick here to the Z-axis so we can see that. And that's going to give me a view into the bearings. And I'm going to zoom in here, and let's say I want to call out specific attention to this bearing here. So I've got a markup. I want to add something here, bearing failing here. And I'm going to save that markup as well. So now I've got a couple of snapshots kind of discussing the issue, showing the issue here as well. And let's say now I want to take these snapshots that I put together and I want to bundle them into a story, as I showed you earlier. So that's very simply done by just coming in here and selecting those two snapshots, and I'm going to click Create My Story. And so we see that we've arrived at a very easy and simple way of putting together a story. And as I'll remind you from what I've shown earlier, from a security standpoint, again, your comments are coming in that are aligned with the visuals as well as the bill of material. And again, this bill of material is essentially only just the items that are displayed over here on the left-hand view. So I've locked down exactly what I want my collaborator to see and have access to in a very easy and simple way. Now, another thing that I would like to point out is let's step through the scenario of actually sharing this out here. For this example, I'm going to look at, let's say, an earlier version of this model. And I've got some predetermined issues that I would like to share out with a supplier. And for this example, let's say that I need to reach out to my supplier who's providing us our rotors and our gears. And we've had, for example, a larger wind turbine blade design come in, and it's causing us to redesign our brakes and our gearings, and we need some changes in there. And so what I'd like to highlight here is we've now noticed some issues where our brake disc is a little bit larger. As you can see, some interference here where my cursor is with the brake pad assembly. We've also been able to take some views of it, showing a cross-section view to show exactly where and how much the interference is occurring here, as well as taking now a snapshot and also showing them where our gears are overlapping due to some increased sizing. And I need to get this out to my suppliers so they can review these issues and fix it. So I'm going to now bundle these snapshots into a story, as I showed earlier. Sorry, make sure I get the right ones here. And I'm going to create my story. And I'm going to come in here and now I'm going to name my story. I'm just going to name it Interference Issues in Gearing and Brakes. I'm going to add a description here of please see snapshots for issue details. And again, as I demonstrated before, there's really only one piece that I would like my supplier to be able to pull out from a geometry standpoint and make fixes on, and that's this slide here. So I'm going to come in and I'm going to enable him or this person to only export out the geometry that's shown in this snapshot. So you can see that's highlighted, export here. And now I also just want to come in, and because I've shown a cross-section view here, I want to be able to enable them to do some further cross-sectioning in this snapshot. So now I've got it set. Now I actually want to share this out, and I'm going to share this with an alias account of mine so I can actually demonstrate this for you. And I'm going to send this out. And I'm going to pull up my mobile screen so you can see what this looks like on the recipient side. And it appears I'm having some Wi-Fi issues. There we go. Sorry for the delay. Give me just a second to get my phone connected to Wi-Fi. All right, here we go. I'm going to screen mirror. And so now you've got my phone up on the screen here. And you'll see on my mobile device that I have now received this story. And I'm going to click on this story. I'm going to click review this story. And because I previously logged in and created a username and a password, I'm going to get direct access into this story. So now what you're seeing on my desktop on the left is now being experienced by somebody on the go on their mobile device, as you see here on the right. And I can come into, let's say I'm going to come in while I'm on my desktop, and I'm going to add in a comment here to the supplier about gear interference needs fixed. I'm going to comment. Now I'm going to come on my mobile device, click at my comments here, and you'll see that that comment I just made instantaneously showed up on the mobile device, and the individual on the go on the mobile device can say, yes, I am on it. And they can reply back. And we should see that, that reply pop in here on my desktop. And so, again, a very powerful way of collaborating with heavy product data, literally on any device. And as I mentioned before, the interaction on the mobile is the same as you get on a desktop. Again, because we are doing all of the rendering in the cloud, the experience is very rich on any device. Now let's just say we've brought in a new version of this model, and I've gone through great lengths of putting together all of these snapshots and sharing this story out. And I don't want to have to go back and redo all of my snapshots simply because a new version has come in. And so let's imagine that this supplier has made all the updates that they need to these different components. I've uploaded a version 2 into it. And so now what it's saying, if I'll draw your attention here to my desktop screens, you'll notice this little red dot. That's indicating that there's been updates to the geometry contained within these snapshots. And what I can do is simply just click Get Latest Snapshots. It's going to confirm that. And now you'll notice here, if I click on this snapshot here, you'll notice that there is now no longer any overlapping gears. My snapshots have been automatically updated. And further, if I come over here to my mobile, you'll see, working on it here, that the view has also been instantaneously updated on the mobile as well. And again, one thing I did forget to point out is that the experience, as I mentioned, on your mobile is as powerful as being on a desktop by being able to interact with that model in a very powerful way. So I hope that's been informative a little bit here on the demo side of it. And go back to some closing slides. And so just in summary, as I mentioned earlier, really companies are looking to make decisions quicker, and they need to pull in the right individuals in order to make those decisions. And companies have traditionally been challenged to get that data out of engineering and in the hands of people that need to look at it and make innovative, collaborative inputs to be able to get to a decision quicker. And so really at the core of it, Vertex is enabling organizations to team and to get to those decisions instantly and in a much quicker fashion. So, yep, and we also, so just to maybe give a little bit of an indication here in the summary of how we make this happen. So as I indicated earlier, being able to bring in your 3D models into the Vertex platform very quickly and easy via upload APIs and the ability to handle neutral and native CAD formats. Being able to reduce that heavy engineering data set, 3D product data set very quickly through intuitive tools like metadata, spatial BOM reductions. Then being able to put together those snapshots, as we're calling them, into a story and being able to securely share that out, as I demonstrated all the different levers to be able to really lace in as much or as little control and security as you need into a story, and then being able to instantly collaborate, as you saw me demonstrate to a mobile device, instantly bring the people that you need into your circle for the ability to be able to get to a decision quicker. That's all I got.
All right. Thanks, John. Thanks again, Ken. We did have a few questions come in, and we've got some time for questions. And again, if you have anything that you'd like to hear a little bit more about from either Ken in his part of the presentation or from John as part of his demo, please feel free to drop those questions in. And we did have a few that came in. So Ken, here's one for you real quick. What is the most common collaboration mechanism you see?
The most common, actually, probably the best answer I can give to that is no collaboration. Most companies are not even using a collaboration tool. What they're doing is allowing the suppliers to sit in their in the OEM's data repository and see all the native CAD data to make their changes. And that exposes intellectual property. It can cause problems between suppliers. One supplier seeing what another supplier has submitted to the OEM, and maybe picking up on information about their competitors. So yeah, I think what I see most often is companies that recognize they need some kind of a tool, but as of today, they're really not implementing one.
All right, thanks, Ken. We had another one come in when you were doing your portion of the presentation with users identifying different installations as their #1 problem. Can you dive into that a little bit more as to why that is the case?
Well, I think some of it, I think, is historical in that, the OEM will have one preferred way that they want to interact with their suppliers, but the suppliers might, for some reason, not be able to use that methodology or that mechanism. It may be too expensive for them. They may have restrictions in their IT organization for the use of something, a particular thing that the OEM has. So they end up doing a different mechanism almost per supplier. Now, on the supplier side, they've also got this similar issue. They work with more than one OEM, and each OEM, they're going to have to try to bend over backwards to try to support the interfacing mechanism that a given OEM wants them to do. So they end up having multiple implementations. So you get into a situation where a poor engineering designer is standing there saying, I need to share this data with these 3 supply companies because it impacts what they're doing for us. And now I've got to figure out number one, what mechanism do they use? I've got to make sure I know how to trigger that mechanism and then make that happen. So I'm doing it 4 different times as opposed to once.
Great, thank you, Ken. This next question that's coming in looks like it's going to be directed to John. So John, to what extent is Vertex integrated with PLM tools? And this particular individual called out Windchill PDM link.
Yeah, good question. Thank you for asking that. And as I indicated before, we want to be very clear with our positioning that we're not replacing PLM tools. And this is a great question because it's asking, okay, great, if you're not replacing my PLM tool, how are you integrating into that PLM tool? As earlier mentioned too, just briefly perhaps, we do offer upload APIs. And we would work with individual organizations and companies with their specific PLM tool to develop the necessary call programs to sync with your PLM tools. And we would work with those individuals and organizations to also set, okay, at what frequency do we want the transfer of data to happen from the PLM tools such as Windchill PDM Link to be able to upload into the Vertex platform. But again, we would work with you to develop those specific API calls to be able to make it as seamless as possible. So good question, thank you.
Great, thanks, John. Here's another one that's going to be directed to you, John. How would Vertex work with my supplier if they don't have a Vertex license?
Yeah, good question. So as you saw me kind of demo there a little bit earlier, I demoed out with an alias of mine just for the sake of demonstration to a supplier alias. But in an everyday example, you would still be able to type literally anyone's email address that you want to collaborate in, and they would get a link in their email, and they would be sent a temporary password. And when they first log in, they would be prompted to create a password, and it would enable that supplier, even without a paid or purchased license, to be able to access that story and that story only, but still to be able to provide the capabilities of collaboration and commenting, exporting out if so enabled. And so we do provide very easy and intuitive ways for individuals who don't have licenses to be able to enter into collaboration.
Great, thanks, John. Another one for you about the model versioning. So obviously we saw this question came in when you were pointing out the get new snapshot feature. We have a question about how does versioning sync with the platform?
Yep. So I kind of glossed over it real quick there, but you may have seen me kind of flip back and forth between version 1 and version 2. You initially upload a file, obviously it gets tagged as the version 1, and then you can simply bring in a new version of that file, and instead of entirely wiping out the old version, it's just simply overlaid as a version 2, and it enables you to alternate between different versions so that you can see the thread of changes if needed, go back and understand what collaboration happened and what it looked like in a previous view. But again, it's a very simple way to just bring in a new version and overlay it on top of the old one.
Great. Well, thank you, gentlemen. I believe that's going to be all of our time today. If we did not get to your question, then we will be certain to follow up back with you and answer any additional questions that you had. So thank you very much for joining us today, and have a wonderful rest of your day.